Okay, so over the last few days, we have been talking more about technology and engineering. Let's review some of our major points. So you can tell me, what is engineering? Yes, Trixie.
Engineering is the use of scientific principles to construct or design vehicles, buildings, etc.
Perfect. Yep. As usual, Trixie, really good answer. So everyone, please make sure you're listening to Trixie's explanation, okay? So engineering is the use of scientific principles to design and build machines, structures, etc. Things along those lines, okay? Something else that we have been looking at is criteria. You can tell me, what are criteria? Okay, Baldy.
Criteria is the needs and wants of a thing.
Yeah, okay, that's good. So criteria, need and want from anything that we're building, anything we want it to do. Good stuff. What are constraints? Who can give me an example of a constraint? Hun.
A constraint of something is like when you want your iPad or so iPhone needs to be this, but if it's too expensive for you to buy that phone if you want all the criteria.
Is that okay, let me ask that again. Is that a constraint for you or a constraint for the iPhone? Remember, a constraint is a limitation, right? So we were talking about a car, for example. A limitation of that car would be that it can only go so fast. It can't go any further, it can't go any faster. So a constraint is something that limits it. Another example would be a cup, okay? Criteria of a cup is that it holds liquid, you can put into it, has a handle that you can drink from. But a constraint will be the amount of liquid that you can put into the cup. You can only put so much in. If you turned around to me and said, I want 8 liters of coffee, but your cup only holds 200 milliliters, well, that's not going to work. That's a constraint of the cup, okay? So a constraint is a limitation, is something that an item or a product can only do to a certain point. After that, it just doesn't work. So if I told you that a room can have 200 people in it, we can put 200 people in one room, but there are 220 people, well then the room will not be able to hold 220 people because there's already 200 people in the room. So a constraint or limitation of the room is that it can only have 200 people in it. Kimmy, give me an example of criteria. Give me one criteria example, a criterion. Okay, let's take a phone. So what do you want a phone to do? What does a phone need to do?
To be small.
Too small? Flat, okay. What else do you need it to do?
Comfortable.
Comfortable, okay. Yeah, you don't want a pointy phone. You want a phone that fits in your pocket. These make sense, right? So you have a phone. Say, okay, what do I want this to do, or what do I need it to do? As Kimmy said, one, needs to be small enough so that it can fit in your pocket. Needs to be flat. Imagine you had a very, very pointy phone and you put that into your pocket, it would not be very comfortable. It needs to be comfortable. You need to be able to hold it in your hand and it not be able to hurt you. These are all things that you want a phone to do and you need it to do, okay? A constraint would be is like, well, hold on. You want the phone to be small, but at the same time, you want it to do this. So a constraint would be, well, it has to be this size, okay? And that's the way I want you to think about it. Something else that we have been looking at is understanding questions which come to deciding how to build your product. So for example, if I was to show you a notebook, okay, what do you think a notebook was designed for? What question do you think a notebook solves? Lucy, what do you think?
Design for writing information.
For writing information. So if you were to make a question the engineer would solve, what do you think that question would be?
How could we write information and then keep it?
Yeah, perfect. How do we write it? Go on.
Yeah. So if we write in a paper, we can just throw it away, and
Okay.
it's very easy to lose it.
Yeah, fair enough. Good idea. Okay, so yeah, Lucy's right. So a notebook was designed to answer the question, tell me something that I can write in and that I can keep. So can I keep it all together? So someone said, you know what, let's get all these pieces of paper, put these paper together and put them in a notebook. Then you get an engineered solution to the problem, which is how do I keep all my pages together? How do I get them to work together? We spoke about researching. We spoke about the importance of researching. Why is research important?
We need to research out the things, so we could have some ideas to.
Yeah, no, you're on the right track. So research is important because it allows you to look deeper into a particular problem, look deeper into finding a solution to a particular problem. Remember, we said that research is looking into something so you can be as accurate, to be as correct as possible. The more correct and the more information you have about a particular problem or the history of a particular scientific principle, or looking into see if something's ever been done like that before, it allows you to pick up patterns, pick up trends, and see what works and see what could work for you. We spoke about looking in nature. Why do you think nature is a good place to look when doing research about designing a product? Rosie?
Because it have a lot of living things and animals for we to do a good research.
Yeah, pretty much. It's not wrong. It's definitely a good start. Rosie's answer was that there's lots of plants and animals to learn from, okay? So nature's always a really good place to look because plants and animals are natural engineering. This is engineering that's happened without the aid of humans. They've done it all on their own. They found solutions to problems that we didn't know, such as seeing in the dark, climbing up walls, staying cold or staying warm in really, really cold places. Animals have done this, and they've done this through years and years and years and years of evolution and natural selection. So an engineer can obviously have a look at this and say, hold on, what can I take from an animal, or what can I take from a plant? What did they do that we as humans could use? So that's why having a look at nature is a really, really good place to start looking when you're doing some research. Why else would you look in the past? What would you look into the past for? Let's try. Come on, Winter, you've been very quiet today.
So that we can improve the technology of the future.
Yeah, there we go. That word improve is a really, really good one. That's something that we're going to look at today. So I'm going to use that as a springboard to get into the lesson, okay? So what I'm going to do is I'm going to show you my screen, and we're going to go through some of the things that we went through yesterday, but only very, very quickly, just to remind you about what we were actually looking at, okay? So yesterday, what we did was we looked at some hearing devices, right? We looked at devices that have been designed to help people hear at different periods in past. Some of them are very, very simple. Some of them are a bit more advanced, obviously have, taken the time to prove on some of these designs, okay? So an ear trumpet collected and directed sound waves into the listener's ear. So as you can see, what this old man is holding up to his ear is basically like a little cone that you could put onto your ear and allow you to hear better. All of you, I'm sure that when you do this, you are trying to actually hear better, right? If you can't hear something, your first thing that you do in your head is, okay, I'm going to do this. I'm going to try and make this sound come to my ears better. That's what an ear trumpet did. Then there was improvements on it, because obviously a limitation of this is that it can only hear things that are close by. It can't hear things that are far away. They looked at the constraint of being able to only hear things that are close by. So what did they do? They had a longer tube. The longer tube helped direct where the listener could hear sound. So they could not just hear things which are close by, they are then able to point the longer tube in a direction which allowed them to hear things further away. Which makes it a lot easier, okay? Makes it a lot easier to hear. However, once again, the limitation is you have to point it in the direction of where it's going to go. We'll take a stethoscope. A stethoscope is used in medicine. And what happens is doctors will use the cup section at the end, this bit here, and from there, the sound goes into the cup and travels along the tubes to the ears. In doing this, you're able to hear inside the body. Then we looked at concrete listening posts, ears, or acoustic mirrors. They collect and focus sound. They were generally used during the war to hear planes a long way away. The sound waves would go into the ear, like here, like this. And what they would do is they'd bounce around inside. As the sound waves bounce around inside, what happens is you get a louder and stronger sound, meaning that you can hear things which are very, very far away. What I want you to do is help me write this table, okay? So help me. Who can tell me a constraint of the small ear trumpet? Please put up your hands. Trixie, what's a constraint of the small ear trumpet?
It couldn't only hear sounds nearby and could not hear sounds like farther away.
Cool. Good job. Can only hear sounds nearby. Okay, good job. What about the long ear trumpet? Who can tell me? Yes, Winter.
If it is very long, it needs very long to hear far away.
Yeah, okay, not so easy to use because it's so long. Okay. What else? What's another constraint of the long ear tube? Winter again. What I'm gonna do is I'm gonna write this in for you to try help you to. The constraint that really jumps out to me is can only hear certain sounds one at a time, right? Because when the ear trumpet is being used, you need to direct it in the place that you want the sound. If you have someone over here trying to talk to you and your ear trumpet is over there, it's not going to be able to hear it, right? Because your sound is over here. So you can only hear one specific sound at one particular time. So even though it worked very well to hear a sound in one place, it's not going to do very well to hear sounds in other places, is it? Okay. Let's go on to the stethoscope. What do you think a constraint of the stethoscope is? Rosie?
I think the constraint of it is it could only hear in our body.
Okay, can only hear in our body. Who has ever seen? I think you're right, Rosie, but I'm just gonna talk about something. Who has ever seen a movie where they try to rob a bank? They have a stethoscope in their ears, and they are twisting it, and they're listening to a stethoscope. Who's ever seen a film like this? Yeah, there's lots of films like this. So Rosie, I'm going to take that what you said because you're right. They can only hear inside our body, but let's change body to things as well. Okay, they can only hear inside things. Why is that a constraint? You can tell me why only being able to hear inside things is a constraint. So Pro, if I told you that I'm going to give you a machine, this machine is only going to let you listen to things that are inside other things. What is that going to stop you from doing? Okay, Winter, what do you think?
So it can listen the outside thing. It can only hear the inside thing.
Yeah, exactly. So if you have a machine that only lets you listen to things that are inside other things, you're not going to be able to hear things that are outside, right? Now, remember the criteria of the stethoscope is to be able to hear things that are inside, but a constraint would be that can't hear things outside. Also, look at the cup. The cup is quite small, right? So it can only hear one part at a time. A concrete listening post. What's a constraint of a concrete listening post? Go, Baldy.
It is too big.
It's too big. Okay. Why is that a constraint?
Because if you wanted concrete listening post to be in your garage or maybe a house, it would be very, very big.
Okay.
More than a house.
Do you want a concrete listening post in your house?
No.
No. Okay. Okay, I would agree with you to some point. Okay, they are very big. Cannot move them. Okay, we'll take it that way. We'll think about what we need a concrete listening post for. We need it to hear incoming airplanes during wartime, but you can only put it in particular places. You can't turn around and say, okay, it's time for me to move my concrete listening post. And what are you going to do? You're going to go get a truck. You're going to go move it every single time. No. What else? Like, let's take that idea of them being really, really big. What do you think another constraint of that would be? Well, okay, think about this. Need to build them, right? So space to build. Yes, Winter.
If we need to build it, then it will take a lot of time.
Exactly, it can take a lot of time. So all these things will get in the way or constraints of the things that have been built, okay? As Winter said beforehand, that when we look at things in the past, we look to improve them. How do you think we could improve the short-eared trumpet? Okay, Winter, what do you think?
I will improve it by designing to make it hear farther, by not make it longer.
Okay, by not making it longer. Well, I'm gonna take that. I'm gonna counter your argument. Okay, so you've got a short-eared trumpet. The whole point is that this little circle here, right, gets all of the sound. Imagine my eye is the sound. So right now you can see my eye just a little bit, but the closer you get, the more of my eye you can see. Sound works the same way. You want to get as much sound in as you can. If you're to make the sound better without making it longer, how is that person going to hear something that's far away? So I would say for this one, to give you an example about how I want you to answer these questions, make the tube longer. There we go. That's an improvement right there. The short ear trumpet to the long tube ear trumpet. What about the long tube ear trumpet? What are some ways that you could improve on the constraints that it currently has? So we said it's not easy to use. I can only hear certain sounds at one time. What do you think we could do to improve on those constraints? To give you an example of the answer I would look for is, I would say, if it is difficult to use, I would design something that could hold the trumpet for you. Okay, make it easier to move. Find a way to take the trumpet away from you having to hold it in your hand the whole time. Find some way you could put it on a machine and move the machine around. That would be a way to improve the long tube ear trumpet. I don't have to say that anymore. So what about a stethoscope? Who can think of some way to improve on the constraints of a stethoscope? Billy, what do you think?
By adding more cups to the stethoscope.
Adding more cups. Okay. What is adding more cups going to do?
To hear more parts of the body.
Good idea. Okay. So a stethoscope with multiple cups.
That is the same.
Now, Billy, I'm gonna take your idea, right? I'm gonna say, let's make a stethoscope and let's add multiple cups. Okay? So we've got 1 cup, 2 cups, 3 cups, 4 cups, 5 cups, 6 cups. What happens now? You've got 5 to 6 cups on a stethoscope. What happens to being able to use it? Does it get easier or does it get harder? You got 1 cup on a stethoscope, right? So a doctor holds it, they hold the stethoscope, they say, breathe, and they listen inside you. Now you've got 5 to 6 cups, and the doctor says, breathe, jump, smile. It gets harder. So it gets a little bit harder to use, right? The more cups you add, the harder it gets to use. But you're right at the same time.
Yeah.
And what about, last one before we finish up for the day, a concrete listening post. Who can think of a way to improve a concrete listening post in the future? Yes, Mr. Baldy.
We can make it smaller.
Make it smaller? Okay, cool. Mr. Winter, what else?
Make it small so that we doesn't take time to build it.
Okay, smaller so it doesn't take time to build. I have a question. If you make it smaller, do you get the same result?
I will design it to be smaller, not take time to build, but
Like
can
this?
hear much better.
Okay, fair enough. I like that. That's very confident, Winter. I appreciate that. I would say if it's difficult to move and you can't move it any place, in the future, why don't you just put it on a truck or put it on a van? Once you put it on a truck, you put it on a van, you can move it from place to place, right? Okay, guys, our time is actually pretty much up, unfortunately. So I'm going to send you a quizzes ID on some criteria and constraints and some research for later on. Please get it complete before the weekend. And then when we get back to class, we can go through all these quizzes together. Bye, everybody. I'll see you again tomorrow. Good job today. Bye-bye.